All right, we're going to look at max and min values. A lot of this stuff is kind of like, oh yeah, that makes sense. But you have to be careful to distinguish between the two. So there's absolute max and mins, and there's local max and mins. So think about what the word local means. Okay, local is like around here, right? So there's a local max if there's a maximum within an interval. Okay, so if there's like a high point on a graph in an interval, it's a local max or a low point for a min. Okay, absolute max and min, think about what that means. Absolute. So what would an absolute max be that's different than just a local max? Possibly, okay. It's there could be more than one local max, couldn't there? If we've got a graph that does this. Okay, which one of those is a local max? Both of them are local maxes. Okay, so if we were asked to find the local maxes, we've got a local max here because it's the highest point in an interval that surrounds it. Okay, same thing here. We've got a local max there because it's the largest point for an area that surrounds it. Which one's the absolute maximum? The one on the right, the taller one. So absolute max means that it is the highest point for all x in the domain, okay? And notice in the definition here, because when you're doing your homework and you're checking your answers in the answer key, it says that it's greater than or equal to. So if there's several values that have that same value, they're all absolute maxes, okay? That's not usually something they test on the AP test because different books have it different ways, but in this book it says that if it's greater than or equal to, so if there's a bunch of them, or it's like a line that goes across and all that whole line is the highest point, then every single point on that line would be an absolute max, okay? Same thing, absolute min, same idea, okay? So any questions on that before we try a couple problems? Okay, so first one here, find local and absolute max and min values. This is something else you have to be very careful of on your AP test. You will be tested on this on your test in here and on the AP test. When it's asking for the values, it's asking for the y values. So if you just give me the x's, you're actually not going to get the points for it. And they do that on multiple choice sometimes. They will ask you for the absolute min value of the function, and a lot of people will say it occurs when x is 2. And 2 is an answer on multiple choice, but it's not the correct answer. It's actually looking for what the y value is, okay? So if they say values, you're talking about the y value. Okay, so think about cosine. What does a cosine graph look like? It goes like, starts up at 1, right? And then it goes down to -1, and then it goes up to 1, goes down to -1. So if we're talking about local, what are the local maxes going to be? Sorry, this is going to look awful, I know. Close enough, you guys get the idea, and it keeps doing that, right? So wouldn't all of these be local maxes? Okay, and the local mins would be every single one of these. Where would be the absolute max? Same thing, right? Wouldn't every single one of those be because they have the same value? So here it's asking for the local and absolute max and min values. So let's say here, local and absolute max value is equal to +1. And the local and absolute, don't use those on the AP test, min value would be what? -1, right? Okay, think of the graph y equals x squared. What does that graph look like? Parabola, right? Okay, so we've got a parabola, goes through, the vertex goes through what? 0, 0, right? This would be the origin. So do we have any local mins? Yeah, do we have an absolute min? Yeah, so that part is the local, and absolute min. The value is the y value, which just happens to be the same as the x value, is 0. How about max? Do we have any local or absolute maxes? No, it goes up forever. Okay, so there's no max of any kind there, right? Okay, think of y equals x cubed. What's that graph look like? Anybody know? Kind of. Okay, it doesn't go up and then back down though. When it's x cubed, think if you plug a few points in if you needed to. Plug in 0, you get 0. Plug in 1, you'd get 1, right? 1 cubed. Negative 1 would be negative 1. And even if you did something in here like a half, when you cube it, it'd be an eighth. So it kind of curves up, kind of like a parabola up here. And then this is symmetric about the origin, so it does the same type of curve down here. Close enough, right? So what's going to be true about maxes and mins? There's none, right? Questions on that at all? Okay, the next page of the notes doesn't actually have a question that goes with it. I think I just keep forgetting to type a question that goes with it, so you'll have to write one in. What we're trying to do here is we're trying to come up with the maxes and min. So let's just say find the max slash min value, or max slash min. Let's just leave it at that. Okay, now it depends on what the question's asking. If the AP test is asking for values, you're listing the y's, right? Sometimes it'll say find the x values where the maxes and mins occur, so then obviously you list the x's. So we'll list both of them here. Okay, looking at this, we're going to kind of estimate off of the graph. I don't expect you to put that in your y equals. Actually, I think that for some reason there's something here that doesn't match something here, so we're just going to ignore that for this problem. You guys would never know if I didn't tell you, right? Okay, so just looking at this graph, where is there a local max? Right here, right? Local max. Is that an absolute max? Is that at the absolute highest y value of this graph? No. There's higher spots over here and higher spots over here. So we are only going from -1 to 4. Okay? This isn't something where we have arrows on the end. Okay? It's just going from -1 to 4. So this here is a local. So let's go ahead and say that. Local max value of, let me see what that value actually is. Local max value of 5. I know that would be kind of hard to tell based off of this. And then I'm just going to say it happens at x equals 1. Okay, so I'm kind of answering both pieces to the question there, what the value is and what the x value is where it occurs. Okay, so let's try this one. What is that one going to be? A local min. Is it an absolute min? No. Okay, so this one's just local min. And the value is what? 0 at x equals 0. Now, if you're using your calculator, I would double check that to make sure, but we're just trying to do it based off the graph so we can tell the difference between these. Okay, how about this one over here? Yeah, it's both. It's local and absolute. So local and absolute min. And the value there is, let me see here, -27. But obviously, it'd be something where you could just kind of look at the graph if this was something in your book or on the AP test, or you could put it in your calculator to find that if you needed to. Okay, local and absolute min value of -27 at x equals, looks like 3, right? So any questions on that one? Okay, now the only other thing that you have to pay attention to here, which we haven't discussed yet, is, okay, local maxes have to have an interval around them. So local maxes and mins cannot occur at endpoints. Okay, so let's write that here. Can't occur at endpoints. Okay, they have to have an interval around them. An absolute max or absolute min, that's the very highest point, the very lowest point on the graph. So if the graph ends on the ends, it doesn't have arrows going up, so it doesn't continue on forever. So it's like this type of a problem where it stops here, it stops here. There can be absolute. Okay, so which one of these appears to be the absolute max? This one over here, right? It's a little bit higher up. So that is an absolute max. And the value is 37 at x equals -1. So questions on any of those concepts? So this one over here is absolutely nothing, correct? Because it can't be local. We know that because it's an endpoint. It's not the absolute because it's not the very highest. So this one here is nothing. Does that help clarify some of the things about absolutes and locals? We feel okay about that? Okay. Extreme value theorem. Theorems always sound like, I don't know, kind of scary just because I always thought they were. A lot of these actually aren't crazy difficult to understand when you get better at reading mathematics, which definitely isn't something that just comes to you. Okay, so if f is continuous, so that just means there can't be breaks in the graph, those type of things, right? You can't pick up your pencil. So if f is continuous, then f has to have an absolute max and an absolute min value at some numbers in that interval. So if we're going from here, and we have a continuous function, and it goes to here, there has to be an absolute max and absolute min. So it says here the absolute max value is f of c, so that would occur at c. So isn't this where the absolute max is on that graph? So I'm going to call that c. So then this would be the function at c, which would be your y value, whatever that is. Does that make sense? So where would D be located? At the bottom of this one, right? And then this here would be called f of D. Does that make sense? Okay, so let's try a different picture here. Let's say I go up, and it starts to curve back. It looks terrible. Let me try it again. Same idea though. Curve up, and then curve back down. Okay, so where would C be located? C is the max, it says. So that'd be like here, right? So and this would be my f of C. And where would D be located? At A, right? This is where D is. So an f of D would be the same as f of A in that case. You guys okay with that? Okay, one more picture just because this could happen. You could start, let's say like this, and let's say it achieves that same maximum again, and pretend those are exactly equivalent. They're pretty close. So then instead of just having a C value, you're actually going to have two separate C values with that same height, right? So there's a C1 here, we could call it, and another maximum over here, but they would have the same Y value that goes with that. And then here happens to be D because it's lower than both of the endpoints. but again, that could happen at an endpoint. Okay, so what's down here in blue is kind of an easier way to think about it. A continuous function on a closed interval has a max and min value. Okay, so there has to be a max and min. You can't say it doesn't exist. Okay, now down here, you just have to be careful of what it's asking you. It says, if f has a local max or min, and the derivative exists, so it just means there's not like a corner in the graph, so you can find a slope, then the derivative equals 0. Okay, so look at these local max or mins. We're not talking about endpoints, right? An endpoint cannot have a slope, because if you think about trying to calculate a slope of an endpoint, there's not like two values that you could use to come up with that. Okay, if it continued on forever, then you could find a slope at that spot, but an endpoint cannot have a slope. Okay, so it has to be a local max or min. So look at this, let's say local max here. Do you see how the derivative is 0? The slope is 0 there. Same thing here, right? Same thing here, 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 here. Okay, so this is true. So does this mean that if the slope is 0, there has to be a max or a min? No, look at this example. Doesn't it have a slope of 0 right here? Does that mean that it has to be a max or min? No. So here we're going to go ahead and we're going to say no, and we can literally just point to that graph. Okay, and this graph is there just because some people pointed out, well, what about the absolute value? So if f has a local max or min at c, doesn't this one have a local max or min at c? Has a local min there, right? It's the lowest point on that interval. But does the derivative exist? No, because it's a corner to the graph. So that's why this one ends up working. The derivative doesn't equal 0 in that case, but it doesn't fulfill this part, so we don't even have to look at what's back here. Okay? But if it was a parabola, would it work? Yeah. Okay. Critical number. Critical number is kind of a big thing in calculus. You'll see that if you take calculus in college for sure. Okay, so a critical number of a function is a number in the domain where the derivative equals 0 or the derivative does not exist. So whenever it's asking you to find critical numbers, the first thing you want to do is what? Take the derivative, right? So go ahead and take the derivative of this. I'll give you a minute head start. And when you do the derivative, what I would try to do, because you're going to end up using product rule here, so you're going to have two pieces, I would try to get a common denominator and turn it into one piece. Okay, so I'm going to give you like a few minutes to try to do that. If you do it wrong, we can always just do it again. Okay? Okay. So this is what we should get to when we take the derivative. Okay, we're trying to find when the derivative is 0. Which part of this is equal to 0 when the fraction's 0? The top. So you'd set the top to 0. That would give you this part of it. And then to get when it does not exist, that's when what? The bottom 0. Okay? So that's why you want to get it as one fraction. Let's go ahead and try that. So taking the derivative. This is a product, so I'm going to leave x to the 3/5 alone. You just pick one, leave it alone, and then you take the derivative of the other one. So what is the derivative of this? -1, right? And then plus, I'm going to leave the 4 minus x alone. And then the derivative of this one is 3/5 x to the -2/5. Everyone okay with that? So any questions on that part? Is that what you guys got? Okay. So now here, this is just a minus, so I suppose I'll put that behind this one. And this one's obviously a positive piece here. I'm going to write this as a fraction. So the 3 is on top, the 5's on bottom. This I'm going to move to the bottom. So on top I've got 3 times 4 minus x. And then bottom I've got 5 and then x to the 2/5. Do you see that? Questions on that? Okay, so that's that piece in the back. I'm just going to move it to the front. And then this piece here is a minus x to the 3/5. So I'm just going to write that as x to the 3/5 over 1. And you wouldn't have to do that with a derivative. Again, the reason I'm doing it is because I want to set the top to 0 and the bottom to 0. It's easier to solve that part of the problem. So the common denominator is 5x to the 2/5. So this one I need to multiply by 5x to the 2/5. So you do that on top and bottom. This one you don't have to multiply by anything. So my common denominator, when you're adding or subtracting, you'll leave the denominator. And then you add or subtract your numerator. So this I'm going to distribute out in this step. So I've got 12 minus 3x. Let me know if I do something wrong. And then back here I've got minus 5x to what power? What do I do when I have the same base? You add your exponents, right? So 3/5 and 2/5 would give you 5/5 or 1, right? So that's just to the 1 power. So do you see how this turns into that? Questions? Okay, so this is what f prime of x is. So prime kind of went away. So now I want to find the critical number. So I'm going to find when the derivative equals 0 first. So I'm going to say here the derivative equals 0 when, and we said the derivative equals 0 when the numerator is equal to 0. So the easiest way to do this so I don't have to deal with negatives is move this over. So I'm going to add the 8x over. And then divide by 8. So if you divide by 8, you get x is 12/8, or 4 goes into the top 3 times, and 4 goes into the top, or the bottom 2 times. So 3/2 would work there. Questions on that part? Okay, and then the other part is the derivative. Let's say does not exist. I was going to say is undefined, but just keep it with the wording they're using in here. When the denominator, so 5x to the 2/5 equals 0. Now this one's pretty easy because you can just plug 0 and you can see that. If you're trying to solve stuff like this for other types of problems, you divide by 5 first, right? And then how do you solve something that's x to the 2/5 equals whatever this number is? Kinda, yeah. So you're doing the square root and then you're raising it to the 5th power. Or you can raise this to the opposite, or not the opposite, the reciprocal of this. If you did 5/2, do you see how those powers would turn into just the first power? So then you'd raise this to the 5/2. Okay, obviously you don't have to do it for this problem, but there are problems where that type of solution method is needed. So, okay, so here we would just say x is 0. So those both are my critical numbers. Questions on that? Okay, so I'm going to click this here. If you want to write that down, probably not a bad idea. Okay, so if f has a local max or min at c, then it has to be a critical number of the function. Okay, closed interval method you're going to use on the AP test. For the closed interval method, I suppose we can just kind of highlight the main pieces here. So it says to find the absolute max and min values of a continuous function on a closed interval. So closed interval method, that means it's on a closed interval from A to B, so maybe from 1 to 5 or whatever it tells you there. Here it's from -1/2 to 4 for the problem below. Okay, first thing you're going to do is find the values of f at the critical numbers. So when it says the values of f, that means what? Find the y values. So you're going to find the y values at the critical numbers. Okay, so they have to be in this interval. So if you get a critical number, let's say for this example down here, if you get a critical number that's 6, do you think you're going to use that? No, it's got to be in that interval because that's the only spot that we're actually looking for a max or a min in, okay? And that will happen sometimes on the AP test. You'll get something and it doesn't answer their question. So always go back and read the question to make sure that you answered it correctly. Okay, the second thing you're going to do is you're going to find the values of f at the endpoints. Okay, so again, the y values at the endpoints, that's easy, right? You just plug the endpoints into your function. And then the largest is the absolute max, and the smallest is the absolute min. So that I probably don't need to highlight for you. Okay, so first thing you have to actually do if you want the values at the critical numbers is what? You want to find the critical numbers, right? So go ahead and find the critical numbers and then plug them into the function. So to find critical numbers, you have to take the derivative, right? So I'll start working on it up here, but you guys should be working on it, checking your work here. So take the derivative, and you're setting it to 0. It's never undefined, right? It never doesn't exist because it's a polynomial. And I would pull a 3x out. So if you factor it, it's way easier to set to 0 than to try to use a quadratic formula. So then you're left with x minus 2. And once you have it factored, what do you do with the factors? Split them, set them equal to 0. So we have 3x equals 0, which just gives you x is 0. And you have x minus 2 equals 0, which gives you x is 2. Okay, so these are my critical numbers. That's not the goal of this problem. The goal of this problem is to find the values of the function at those spots. So I kind of make, usually when they're grading this, they're checking for these pieces. You're trying to find the f value at 0, and you're going to find the f value at 2. Now, something I haven't even looked at yet is, do these fall within the interval that we're working with? Yeah, it's easy to do this and then find your max and min and not even look at that interval until we're plugging in the endpoints. But these need to fall within there, and they do. So we're going to find f of 0, f of 2, and then the other two pieces are the endpoints. So f of negative a half and f of 4. Okay, so I'll get f of 0, and you guys can do the other ones there. They're way harder. Okay, so this was just plugging those values in. We found these. Now you just find the largest and the smallest. So looking at these, this is definitely the largest one. So this is the absolute max. And always write if it's absolute or local, okay? And when we're doing closed interval method, we're only looking for absolute ones, okay? So absolute max, and the value is what it's asking for, so I'm just going to state it, absolute max value of 17. Okay, and then the min is this one, so again, absolute min value of negative 3. Questions on that at all? It's not like super difficult, but you will have to use it on the AP test. Okay. So take the derivative, set it to 0, and the maxes, the absolute maxes or mins either have to occur where the derivative is 0 or where it's undefined possibly. And then the other spots are those endpoints. Remember, the endpoints can be absolute, so you have to check the endpoints. That's where some people forget to do that when they actually get to the AP test. We're going to save this one. It always jumps around every single time. Okay, we're going to save this one for tomorrow, though. It's a little bit more advanced thinking, so we'll save it for tomorrow. Oops, just the top here, obviously. So I would say definitely get a good jump on that tonight. Okay, tomorrow we'll finish up the last problem there, and then, maybe save that last chunk for tomorrow night or tomorrow in class. And if you have any questions, we can look at those tomorrow.